Hello students, today we're going to be talking about scatter plots. Please don't forget to take notes as you go and complete the survey that follows this video. So there's a reason we're doing scatter plots within this unit is because we're focusing on something called the line of best fit. But before we get into that, let's do a little bit introduction on what scatter plots are. Scatter plots shows relationships between two sets of data. Usually they are numerical. So for example, to make a scatter plot, you're given a set of data. So the data that we have here represent the height of a basketball team as well as their weight. And what we do is the height in this situation represents the domain or the x values, and the weight represents the range or the y values. So what we can do is create points out of those two things and then plot those points. So this would be an example of the ones that were created from this data. As you can see, we have points throughout our graph here that are not connected. And it shows a relationship between the weight and the height of the basketball team. So within every scatter plot, we can see some type of correlation. Correlation describes the type of relationship between two data sets. From there, we can create the line of best fit. And this is the line that comes closest to all the points on our scatter plot. One way to estimate the line of best fit is to lay a ruler's edge over the graph and adjust it until it looks closest to all the points. So really, we put the line of best fit in between all the points so that everything looks kind of around that. So there are a couple of examples there. We have a strong or a weak correlation. So if you look at the strong ones, all the points are very close to the line, while the weak one is kind of spread out from the line of best fit. So you see all the points that are really, really close to that line of best fit versus being apart. Then we have the one in the middle. The one in the middle, we can't really create a line of best fit because the points are too scattered around our scatter plot in order to find a line of best fit. We also have the ones on the right there, which are weak and strong. And there is a difference between the ones on the left and the ones on the right, and that's the direction of our points. So that's when we get into the positive correlation and negative correlation. So we can have a positive correlation, and that's when both data sets are increasing together. So everything is going up. As you can see, it's got a positive slope for our line of best fit, and everything is going upwards together. The no correlation, we can't find anything that's in common between them. They're not going up or down together. It's all over the place. And the negative correlation is as one data set is increasing, the other one is decreasing. So, for example, in this one here, what I mean by that is for the first one, as we're going from left to right and the values down here are increasing, the y values are going downwards, so they're decreasing here. So that's what that means by that. So what we can do is find the equation of the line of best fit. Again, there's no single line that passes through every single data point. So we try the one that is the best fit to the data. That's why it's called a line of best fit. So these are the steps that we're going to take. First, you're going to use a ruler, and you're going to place on the graph where the edge of the ruler touches the most points. So you're going to kind of estimate where that is. Step 2 is to draw the line and make sure it's about half of your points are above and about half of the points are below that line. Then we're ready to actually find the equation of the line. The first thing we need to do is identify 2 points to find the slope. Then from there, we're going to substitute the slope and one of the points into the point slope form of an equation of a line. And then we're going to manipulate the equation and solve for y to put it into slope-intercept form. So let's take a look at an example. You do not need to write down every single one of the years and the winning throws. This is just here to know that it is all the data. But the Olympic game discus throws from 1908 to 1996 are shown on the table. Approximate the best fitting line for these throws. Let x represent the year with x is equal to 8 corresponding to 1908. Let y represent the winning throw. So we have ourselves a scatter plot that can be created from these points. So again, remember the year is going to be our x values and the winning throw is going to be the y values. So this would be the scatter plot that would exist. So what I would do is I try to find a point that would be somewhere in the middle where at least half the lines or points are above and half the points are below. And this would be the line that I think is the most appropriate for the line of best fit. Again, if you were doing this on your own, yours could be a little bit above or a little bit below. So this is step 1 and 2, is to draw that line. Now I'm going to identify 2 points and create the equation of the line. So we're going to find the slope between the 2 points on that line. Well, I'm going to identify 2 points. If I look back, I can see it goes right through 1960 and 1988. And so I have 2 ordered pairs. I have 60 and 194.2, and then 88 with 225.8. So remember the slope formula is going to subtract the y values on top and subtract the x values on the bottom. So we'll do y2 minus y1 over x2 minus x1. So in this problem here, you can see that the first point is x1, y1, and the second one is x2, y2. So we're going to take this point and subtract off this point on the left here. And what ends up happening is through all the simplifying, subtracting, and simplifying down, we get 8 over 7 as our slope. Okay, so now that we have our slope, we now need to go find the point-slope form of the equation to eventually get into slope-intercept form. So step 4, we're going to substitute that slope in one point into the slope-intercept form of an equation. So if our slope is 87, let's choose the point 88 and 225.8. So when I go through and I substitute, remember I'm going to put it into y1 and x1 and m. So once again, I'm substituting only in for y1, m, and x1. So if this is x1 and this is y1, and this here, remember slope is represented by m. So when I do that, I get y minus 225.8 equals 8 over 7 times x minus 88. And then when we do this, we're going to take our slope and we're going to distribute it through to both things inside the parentheses. So when I distribute through, I get 8 over 7x minus 100.6. Remember, when I have that 225, I need to move it to the right. So I'm going to add it to the other side because it's originally a subtraction sign. So I'm going to add it to the right. And I get y is equal to 8/7 x plus 125.2. And I get that by adding negative 100.6 to 225.8. So this is the approximate line of best fit. Please keep in mind that when you're solving these, people can get different answers. It's all going to depend upon the points that you're choosing. That was the points that I chose, so I got that specific line, but you could have done something different. However, they should be pretty close. Instead of 8/7, maybe it was 9/7 or something like that. So it should be pretty close to each other. If you have any questions, please make sure you bring them to class tomorrow or enter them into the survey. Complete the survey that follows the video. I'll see you tomorrow.